In this video, we're going to explore the very important act of canceling. So we first need to start off with some terminology. If you have, for example, x added to 5, we have some special terminology associated with this. We call this a sum. And the two things that you're adding together, in this case the x and the 5, each of those are called terms. Okay? So just like you can add two quantities together, you can also multiply two quantities. So for example, if you had 2 multiplied by x plus 3. So this wouldn't be called a sum. A sum refers to addition. This would be called a product. And the two quantities that you are multiplying together, in this case the 2 is being multiplied by all of x plus 3. Those two quantities, the 2 and the x plus 3, those are called factors. So 2 is one factor, and that all of x plus 3 is another factor. Okay, so what would happen then if you had something like this? If you had 2x plus 7, how would we classify that? Now, what's interesting about this problem is that it involves two operations. Actually, the previous problem involved two operations as well. So whenever you have multiple operations, you have to ask yourself, well, is it a sum because there is addition, or is it a product because there's multiplication? And the way we answer that is by thinking about what would you do, thinking about order of operations if you replaced x with a known number. So for example, let's say I knew that x was equal to 5. This would become 2 multiplied by 5 plus 7. And then I ask myself, how would I proceed? What would I do first? Would I add or would I multiply? Well, following GEMDAS, I would clearly multiply, and this would be 10 plus 7. Okay? And then finally, that is right now, I would add, and I'd get 17. So the main point to note is this. Do you see how the first operation I performed was multiplication, and then the last one was addition? Because the last operation was addition, I would call this a sum. So likewise over here, I say, okay, there are two things to do, and if somebody gave me the value of x, I would first multiply, and finally, that is the last operation I would perform is addition, and that's why this gets classified as a sum. Okay? And looking back at the previous problem, I can actually see why this is called a product. If somebody gave me x, what would I do first? Well, I would first take that x and I would add 3, because the x plus 3 is in parentheses, and GEMDAS says do that first. So I would first add, if x was like 5 for example, I'd get 5 plus 3 and that would be 8, and then I would multiply by 2, and that would be 16. Because the last thing I did was multiply, that's why I would call this a product. Okay, so let's take another example and just get used to classifying what we're talking about, or classifying the algebraic expression, if you will. So let's say that we had 3 multiplied by x multiplied by 2x minus 3. So now you don't have to always write out, you don't always have to replace x with something. You can sort of do it in your head to get an idea of what you're talking about. So for example, I can see that if x was, 5 for example, I would first take 2 and multiply it by 5, and then I would subtract 3, and I'm doing that first because there are parentheses, and then I'd multiply 3 by the 5 times whatever I got there. Now because the last thing I did was multiplication, that's why this would be a product. Now sometimes it's helpful when you identify an expression as a product to identify the factors. Now the factors are what you are multiplying together. So in this case, the factors would be Let's see, what are we multiplying together? Well, 3 would be one factor, x would be another factor, and the 2x minus 3 would be the third factor. Now, why would we take the time to do that? Why would we bother with identifying the factors? Well, think back to how we simplify fractions. So, for example, if you were asked to simplify and you had 15 over 20. How did we do that? Well, what we did is we wrote the prime factorization of 15 and 20, and then we canceled. So we first wrote this as 3 times 5, and then the denominator 20 is 2 times 2 times 5. That's the prime factored form of 20. Now notice at this stage, when I said the prime factored form, that implied we had multiplication. Now when you have multiplication, then you can cancel factors. So if you want to cancel, you have to make sure that you have a product. And what you do is you cancel common factors. So the common factors here are the 5. So I'm left with, in this case, 3 over 4. And what made everything work is the fact that we were able to write the 15 and the 20 as products. And so the same logic is going to apply when we see a little later on when we go to simplify something like this. So we're going to be doing this a little bit later when we have something like x squared minus 9 over x plus 3. So the first thing to notice is that we can't do any cancellation right away. Why? Because the denominator is a sum, I can see it's addition, and the numerator is a difference. And you can only cancel, like in the previous example up here, you can only cancel when you have multiplication. So in this case, we're not yet ready to cancel because I don't have addition or I don't have multiplication. Okay, so let's go ahead and look at an example where you can cancel. So let's say that you were asked to simplify. And by the way, later on we will be able to factor the numerator and the denominator, and then once we did that, we would be able to cancel. Okay, so simply because it's a sum or a difference in the very beginning doesn't mean there's no hope. Okay, so let's say that we were looking at 3 multiplied by x plus 7 divided by 3. So I ask myself, okay, am I able to cancel? Well, I'd certainly like to be able to cancel the 3's. The question is, can we? Well, you can only cancel if you're canceling factors. And so I ask myself, is the numerator a product? And if so, is 3 a factor? And it is, right? Because I see the numerator is 3 multiplied by x plus 7. And so if I had to list the factors of the numerator, I would say they are 3 is one of them, and x plus 7 is the other. And likewise, the denominator can be thought of as, well, it's 3, but it can be thought of as 3 times 1. And now we're in the situation that we were in before up here, where once you identify factors, you can cancel the common factors. So in this case, the 3's would cancel, and I'm left with x plus 7 over 1, which is just equal to x plus 7. Okay, so whenever you go to cancel, you have to make sure that you're canceling common factors. Okay, and this is going to be really useful for us, or to us, when we go to solve equations and simplify more complicated expressions.